Okay, so this video is going to explain section 6.1, which talks about angles of polygons. Chapter 6 is all about quadrilaterals and parallelograms and that kind of thing and the relationships that they have. But today we're talking specifically about the angles inside and outside of polygons. Remember, polygons are just any closed figure with non-curved sides. So typical things like squares, hexagons, octagons, that kind of thing, they're all polygons. Okay, so you should have gotten the blue sheet from the sub. You should fill that in as you go. You can use either like the back of it to work examples out to help you. That'll help you with your worksheet. So here we go. So the polygon interior angle sum theorem. So what that's saying is that there's a theorem that tells you how many degrees the inside of a polygon is. So for example, if you had a pentagon, something like that, it'll tell you how many degrees are on the inside of a pentagon. Just like how we know the inside of a triangle is 180 degrees. Some people might know inside of a square is 360 degrees, that kind of thing. This is a theorem that tells you about all sorts. So the theorem formula is n minus 2 times 180 degrees. Okay, so n stands for the number of sides. And we can see that works specifically with the two examples from down here because a triangle has 3 sides, and if we plugged 3 in for our n, we'd have 3 minus 2 times 180. 3 minus 2 is 1. 1 times 180 is 180 degrees, and we know in a triangle that there's 180 degrees. So you can use this formula for any type of polygon. It doesn't have to be regular. As long as it's a polygon, you can use that to see how many degrees are on the inside of the figure. So for example here, it says find the sum of measures of the interior angles of the figure. So you count how many sides it has. So it has 4 sides. And then you apply the formula, which was n minus 2 times 180. So we plug in our n. So then we get 4 minus 2 times 180. Which gives us 2 times 180, which is 360 degrees. So the first section of your worksheet, I think it's the first 6 problems, are these kind. Let's try another one. So this is a pentagon. How many sides did it have? Well, it has 1, 2, 3, 4, 5. So your n is 5. We can plug into our formula. So we get 5 minus 2 times 180. It's always minus 2. That's what the formula says. This is the only number that changes. So 5 minus 2 is 3. 3 times 180 is 540 degrees. So that would be your answer. Okay, go ahead and try this one on your own, and then so pause it. Once you're done, press play so that way you can see me walk through it. Make sure you got the same answer that I did. Okay, so this one has 2, 3, 4, 5, 6, 7 sides, so our n is 7. We plug into our formula and we get 7 minus 2 times 180 degrees. 7 minus 2 is 5. 5 times 180 degrees is 900. So 900 degrees would be your answer. Again, this is how you do the first 6 in the worksheet that you're going to get. Okay, the back part of your worksheet is stuff that looks like this. So there's 2 steps in doing this. The first thing you need to do is you need to find the sum of the angles. So just like what you did in the last 3 slides. So you count how many sides it has. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we're going to use our formula here. 8 minus 2 times 180. And we're going to get 6 times 180. And 6 times 180 is 1080 degrees. So that means the interior of this octagon has 1080 degrees. Now, just like when we do triangle stuff and we'd add them up and set them equal to 180, you're going to add all of these up and set it equal to 1080. So I'm going to take x plus 130 plus 145 plus 110 plus 125 plus 140 plus 150 plus 120, and that's going to equal 1080. Okay, we keep solving from here. Move this down a little bit. So the second step then is to add them all up, set them equal to what number you found here. So I have 1x, and if I add up all of these numbers together, let's see, I have a calculator, so 130 plus 145 plus 110 plus 125 plus 140 plus 150 plus 120. I got 920. Okay, then I would subtract 920 from each side. And I get x equals 160. So that would be your answer. So again, for these type of problems, you first figure out what the sum of the angles is like you did in the last slides. Then you just add them all up, set them equal to that number, and solve. Okay, here's one more example like that. So right now I want you to pause it and try it. Then when you're ready, press play. So pause it. Okay, so this is a pentagon, so we have 5 sides. First thing we need to do is find out the amount of degrees that are inside the pentagon. So 5 minus 2 times 180 is our formula. So then 3 times 180, which is 540. So it means we're going to add all of these up and set it equal to 540. So I'm going to take 9x plus 18 plus 10x plus 16 plus 11x minus 2 plus 10x plus 12x minus 12, and then set that equal to 540. Okay, I'm going to add up my x's here. Let's see, so 19x, 30x, 40, 52x. I'm going to add up my numbers, so 18 plus 16 is 34, minus 2 is 32, minus 12 is 20. Subtract 20 from each side, and I'm going to get 52x equals 520. Divide both sides by 52, x equals 10. Alright, one more part of the interior angles of a polygon. Just a review, what does it mean if a polygon's regular? This is something we talked about back in chapter 3, I think. We said a polygon's regular that it has all equal sides and angles. So, and then it was equiangular and equilateral. So for example, you could have a pentagon like this and have all equal sides and all equal angles, but something like this is also a pentagon. Okay, it has 5 sides, so it's considered a pentagon, but it's not regular because all the sides and angles aren't equal. So for the last stuff you're doing, it doesn't have to be regular to do that. You know, with any polygon. But this applies to only regular polygons. And all the ones that you have examples of are going to be regular, so don't have to worry about it. So this is saying so we found the sum of the angles, so inside a triangle, for example, it's all 180 degrees. We want to know what each individual one is, and we know it's a regular polygon, so therefore they're all going to be equal to each other. So for example, we knew in a triangle that it was 180 degrees total, and we knew we could just divide that by 3 to figure out that each one of these were going to be 60. So we can apply the same logic to our formula. We just take our n minus 2 times 180 like we used before, but then when you're done, you're going to divide by n. And remember, n stands for the number of sides. So we're going to run through some examples of that. For example, this is a hexagon and we have 6 sides. So with our formula, remember our formula looks like this. We're going to plug in our n, so 6 minus 2 times 180 divided by 6. We plug in our n for both of these. Okay, 6 minus 2 is 4. 4 times 180 is 720. And then you take 720 and divide it by 6. So that's saying that each one of these individual angles, it's regular, so they're all equal, are going to be 120 degrees, which makes sense because all 6 angles together have to equal 720, so we just divided that by 6. Okay, let's run through another one here. This is a 1, 2, 3, 4, 5, 6, 7, 8, 9, so it's a nonagon, so n is 9. So we just plug in our formula, so n minus 2 times 180 and divide by 9. Okay, so then we take 7 times 180, divide by 9. 7 times 180 is 1260. And then divide that by 9. and we get 140. So each one of these individual angles is going to be 140 degrees. This would be the second part of your worksheet. So the first 6 were the sum of all of them. The second 6 are just the interior ones individually. So go ahead and pause it. Try this one on your own. When you're ready, press play. Alright, so 1, 2, 3, 4, 5, 6, 7, 8. Octagon, so n equals 8. So we're going to take 8 minus 2 times 180 divided by 8. So 8 minus 2 is 6. And 6 times 180 is, let's see, 1080. And then we divide that by 8, and we get 135. So each of the individual angles are 135.